So let me introduce myself. I'm Victor, and as it says on my Twitter profile, I make Angular, or to be more specific, I'm an Angular core team member. And for the last couple of months, I've been working on the Angular router. And today, I'm happy to show you how it works. By the way, you can follow me on Twitter or read my blog. Most of it is about Angular and TypeScript, so you may find it interesting. All right, what is this talk about? This talk is not about, it's not an introduction to the router, even though I will do a bit of that. This talk is about lazy loading. Supporting transparent lazy loading was the main design goal for us when building this router. And today, I'm happy to show you how it works. That's what I'm going to cover. First of all, I'm going to talk about a status update of the router project. Because if you follow the project, you know that we made a few attempts to build the router, and it kind of sucks. It took us so long to get here, but I think the result is actually really good, and it works really well. After that, I'm going to give you a 5-minute introduction into the router for those who aren't familiar with the project at all. Then I will talk about lazy loading, how to do it and why you should do it. After that, I will talk about preloading, which is a clever optimization we can use to make our applications perform even better and bootstrap even faster. And finally, I will talk about bundling. All right, so the status of the project. So the router is stable. We released the final version a couple of weeks ago, and you can read the announcement if you go to that URL. The router is well documented. You can find a lot of articles, blog posts, guides, API docs online. I wrote a book about the router, which you can find online as well. It's used inside and outside Google. And I think what's most important is that same as the core framework, it's going to follow Semver, and it's going to have the same release schedule, meaning that in the next year, we're not going to make any breaking changes to the router. Okay? So it's going to work sort of exactly the same way. Whew, and that's really good. And even after that, I'm not planning to make any substantial breaking changes, just like minor cleanup. So the message is, yes, it's stable. You should rely on it, and you should use it in production. It's fine. It sucks. It took us so long to get here, but it's good. It's ready to be used. All right. Before I talk about lazy loading, I'd like to give you a 5-minute intro into the router, just in case you don't know what the project does. So what does the router do? It's fairly simple. The router takes the URL and the router configuration that the user provides, the developer provides, and it uses this configuration to construct a router state out of the URL. Finally, it uses the state object to instantiate all the needed components and place them into the right places in the component tree. Then anytime the user clicks on a link or navigates imperatively, the router updates the URL, constructs a new router state, and does the whole thing one more time. It compares the new state to the old state and updates all the components accordingly. So the router's primary job is to manage navigation between states, which includes updating the URL and updating the component tree. All right? Let's look at an example. So imagine you have an application, like a mail application similar to Gmail or Inbox, with 2 sections, the conversation section on the left and the contact section. And say at launch, we display only one section. Yes, we display only conversations. And if you click on the contacts button, we show the second part of the application, which is a list of contacts. Each of these sections, in our case, is represented by 2 components. And from the router's perspective, those 2 components are opaque. The router doesn't care what those components do. All right? So this is the router configuration for this application. Let's focus on the first route. This first route describes the conversations part of the application. As I mentioned, the router will take the configuration and will match it against the URL. This particular route, for example, will match these URLs. So the router has a very powerful URL matching engine, which I won't cover in this talk, but hopefully you can sort of see why this configuration matches these URLs, intuitively at least. The structure of the configuration, the shape, so to say, matches the URLs. And the contact section works analogously. Finally, we take this configuration and we pass it to router module.forRoot, which is responsible for creating the router service and for adding the router directives to the current compilation context. All right, so that was the configuration. We can also navigate around, and we can do it by either using the router link directive or by doing it imperatively and calling navigate. So I hope you can sort of see why it works okay together, why it all works together. Yes, we have the configuration we use to parse the URL into the router state, and then we use router links to navigate to new URLs, and then the process repeats. So this setup works, but it has one problem. And it's that the router configuration refers to all the component classes. And hence, we have to have a single bundle. Yes? Even though the context component and the contact component are displayed on load, they're still bundled up with the main part of the application. And as a result, the initial bundle is larger than it could have been. So it takes longer to download, it takes longer to parse, and it takes longer to bootstrap. So the two extra components we saw may not seem like a big deal, yes, but in a real application, the context module can be much larger. It can include dozens or even hundreds of components. And together with all the stuff that they need, all the services and helper functions, this might be a lot of code, yes? So a better setup would be to extract the context-related stuff into a separate module and load that module on demand. And that's basically what lazy loading is. Yes, let's see how we can do that. Our first step would be to extract all the context-related components and routes into a separate module. For example, here I just copy and pasted this configuration from the main file, and I didn't change anything. I just copied and pasted this route configuration from one file to another one. I also created the context module, where I register the context-related routes using router module.forChild. So I use forChild here instead of forRoot, because it's a child module that we are going to load from the root one. And in opposite to forRoot, forChild doesn't create another router service. It just registers routes. And this is important because the router manipulates location. Like we know that location. And location is a mutable global property. So having more than one object actually touching the location is not a good idea. So it's not allowed. So we are done with extracting this new module. What we need to do next is to update the main module to point to the newly extracted one. And it's very easy to do. We just need to replace the children property we see over there with load children, like this. So what does load children do? So how does it work? The load children property tells the router the following. It tells the router, fetch this context.module bundle when and only when the user actually goes to that section of the application. So the router will fetch this file, we'll get the router configuration out of that file, we'll merge this configuration with the main configuration, and then we'll activate all the needed components. By the way, the value you see there, that string context.module, is an opaque token from the router's perspective. So the router doesn't care what it is. It just takes the token and passes it to a module loader. And it's the responsibility of the module loader to load the module, yes, and get the configuration out of it. The default module loader we use is System.js based, but you can provide a different one. For example, at Google, we don't use System, we don't use Webpack. We have a different mechanism for loading code. So we have a different module loader that uses that mechanism. But as an application developer, you shouldn't really care. Yes? From your perspective, it stays the same. The app stays the same. The configuration looks more or less the same. You don't really care what module loader is being used. All right, so after this refactoring, what we have looks like this. The initial bundle has only the components that are displayed at launch. So all the context-related stuff, yes, was moved from the main bundle to a separate bundle. And the main bundle right now refers to the second bundle using the load children property. So we get only the main bundle first, and the router won't load the second bundle until the user actually clicks on some link that goes to the context section. As a result, the main bundle is smaller, so it takes less time to download and less time to bootstrap. Note that I didn't have to update any components, any links, or any navigations in my app. Yes? And this is crucial. Nothing had to change in my application apart from the configuration. All the links, all the navigations, all the components kept working the same way, which means that we can write our application, our code first, and then decide how we want to bundle it, how we want to split it, how we want to load it. The application will work the same way regardless if we use lazy loading or not. And that's why we call our lazy loading transparent. That's because you can opt in and opt out without making any changes to your component, so with minimal effort. And reaching this level of transparency that we provide actually wasn't easy and required a lot of design. And I will give you one example. So we use router link directives to navigate, to create links and navigate around. And this directive handles mouse clicks, but it does more than that. For example, it sends the href attribute on a tags. So the right-click behavior you got used to works. And this happens synchronously without the router loading anything else. Yes, without the router loading the context bundle. So only when the user actually clicks on stuff, the router will load all the needed configuration to navigate there. So this synchronous link generation works only because the router's navigation is URL-based. So our router doesn't have any notion of route names, and that's by design, yes? Because when you don't have any route names, we don't need to use any configuration to generate links. So in other words, link generation is mechanical and application independent. And this is an important design decision we made very early on because we knew how important transparent lazy loading is for us. If we had some sort of notion of route names, this wouldn't work. Yes, we wouldn't be able to have lazy loading transparent. Yes, we wouldn't be able to opt in and opt out of lazy loading with ease. Another note is that in this example, I show that we have two modules, the main module and the context module. But of course, if you have more than two, it works just the same. So the transparency remains, the property holds. So it doesn't really matter how you split your application, how you load modules. You won't have to make any changes to your components. Yes, it will remain working. All right, so let's recap what we've learned. Lazy loading, or loading on demand, is a key capability of the new router. And it makes the initial bundle size much smaller, which has a big effect on time to first interaction. Then it's transparent. Yes, you can opt in and opt out of lazy loading without making any changes to your app. And finally, this transparency shaped the design of the router in many ways. For example, to achieve that, we had to make all navigation URL-based, so we can generate href attributes on links. Okay, that sucks. All right, hey, it works. Boom. I don't know. I just accepted. So basically, I told you that the context module won't be loaded until the user clicks on a link, which is cool because the bundle is very small. We can download it quickly. So it's good. The issue here is that when she actually clicks on a button or on a link, the router will have to fetch the second module from the server, yes, which may take some time. So we can fix that. Yes, we don't want to wait. So what we can do, we can preload other modules while the user is interacting with the app. So we can do it in the background. That's what preloading is all about. That's how it works. We load the initial bundle, which contains only the components we have to bootstrap our application. So it's as fast as it can be, and the bundle is as small as it can be. Okay. We bootstrap the application with this very small bundle. Yes, and the user starts interacting with the application basically very quickly. While she is doing it, in the background, we preload other modules and merge all the configurations. So it works transparently. The user doesn't see it. The application is not stuck. And finally, when she clicks on a link, the navigation is instant. So this allows us to get sort of the best of both worlds. The initial load is very fast because the bundle is as small as it can be, and all subsequent navigations are instant. So how do we enable it? It's actually very simple. So we just need to pass a preloading strategy to router module.forRoot. And the latest version of the router ships with two strategies: preload nothing and preload absolutely everything. Yes? And you can provide your own strategy if this strategy doesn't work for you. And it's actually much simpler than you might think. The two built-in strategies, for example, are one-liners. So let's see how we can write a custom one. All right. Say we don't want to preload everything. Yes? Say it's not a good idea for us. Instead, what we want to do, we want to explicitly say, tell the router, rather, in the configuration what should be preloaded. And we can do it by setting this preload true. Basically, only the rounds that have this property set to true should be preloaded. The rest should be, should not be. So what we need to do is we need to build a custom strategy. And this strategy has to implement this preloading strategy interface. The only method required here is preload, which takes two parameters, a route, and the function that actually does the preloading and returns an observable. So in this strategy, we're going to check that the preload property is set to true, and if it's the case, we're going to call the function. Otherwise, we're going to return a wrapped now, an observable that contains now. Finally, we need to register the strategy, and there are two steps here. First, we need to list it as a provider, and then we need to pass it as a token to for root. So the router will use DI to fetch the strategy, and everything will wire it up in the right way. You know, it all works fine. So that's everything we had to do to enable custom preloading. So once again, I'd like to stress that what we saw right now, preloading is transparent. There is nothing we had to change in our application to make it work. It's a tiny configuration change. This means that we can build our application, and then we can start experimenting with different ways to do lazy loading or preloading. It can be a separate step. Preloading is pluggable, so you can customize it. For example, you can have a strategy which is platform-specific. Say you can always preload on desktop, and maybe you want to save some traffic on mobile. It can even be user-specific. You can remember, for example, what features that particular user tends to use, and preload only that code. All right. The last thing I'd like to show you and talk about it is bundling, because it's super hard usually, but I think right now it won't be. I'm actually very happy with the result. All right. So if you look at this configuration, once again, there is one thing I sort of glanced over and didn't talk about, and it's how we create the bundle, the context bundle itself. Because the router doesn't create the bundle. It just asks the module loader to get one. The module loader just assumes the bundle is there. It doesn't create the bundle. So who creates the bundle? Yes? And of course, you can have your own custom setup where you create the bundle. You can use rollup or whatever your heart desires to bundle up your application. But if you use the CLI or Webpack, we can help you, because we build a Webpack plugin that configures everything for you. There you go. Say this is the TS config for our project. And every TypeScript project has one, regardless if you use Angular Webpack. I'd like to point out one thing here, and it's this section. Note the entry module property. This tells the CLI or Webpack to do the following. It tells the CLI or Webpack to find that module. It's a build step. It's important to understand that. Find that module, get all the routes defined in that module, then get all the load children properties defined in those routes, collect those, and recurse into those. So in this case, we are going to recurse into the context module. So we're going there, and we're going to do the same thing one more time. Yes, we're going to look at all the routes in this module and try to find all load children properties here. Because this module doesn't have any, the process will stop. And this will be the result. This will be the set of entry points the CLI or that Webpack plugin is going to pass to Webpack, which will create all the needed bundles. So bundling is automatic in the sense that if you use CLI or if you use Webpack, the whole configuration consists of one line. The router will figure out stuff for you, or the plugin router will figure out stuff for you. But you don't have to use the CLI or Webpack. Yes, you can do it yourself, but in this case, you may have to provision a few things here and there. So let's recap what we learned today. Yes, first, the router is stable. And it took us forever to make it stable, but it's stable now, so it's good. Second, from the very beginning, we knew that transparent lazy loading is a key feature we need to provide. Yes? So you can build your application first, and then later you can decide how you want to bundle it. And your application should work the same way. So transitioning in and out should be done with minimal effort. We also added support for transparent preloading, so the initial bundle is actually very small. And subsequent navigations are instant, so we get the best of both worlds. And once again, using it is very easy. To opt in, you just need to provide or make a tiny configuration change. Finally, we build a plugin for Webpack. And this plugin, what it does, it traverses your configuration recursively, collects all the information about what the router expects, and creates all the bundles so it matches what the router expects. That's everything I have. So you can follow me on Twitter, which you should. You can also check out my blog, because I write a lot about the router. So if you care about the subject, you'll find a lot of stuff there. I also spent a few weekends writing this book. You can download it. It's very short, takes an hour to read. And if you get to the second link, to the coupon or whatever, you can get it for free today. Thank you.